Is I'm going to be giving a tutorial, kind of give you an overview of foundational models, but more thinking from a software engineering point of view, okay? So this kind of tutorial is prepared with myself, Professor Bram Adams at Queen's University, Professor Jack Jiang at York University, as well as a few folks at Hawaii, Canada. Okay, so I already talked about this, so I'm going to kind of skip some of the material we already talked about. But the key point here is large language models is a term that really is not going to last for long. Foundational model is a term that's kind of moving forward. Looking at IBM, IBM now only talks to its customers using the term foundational models, and that's kind of their strategy, and we're seeing more and more companies moving into that term. Now, this is based on a course that actually we have designed, and we've been teaching it this term actually, where we really wanted to rethink all of software engineering with foundational models in it, right? So I'm not going to be able to do everything in here, but at least I'm going to touch in on some of the key points, okay? And in particular, you know, foundational models and the future of software, what we call AI-ware, okay? So, you know, this is the kind of the standard definition. So foundational models trained on broad data, generally using self-supervision at scale that can be adopted to a wide range of downstream tasks. You know, one of the key things about them and what's people really excited about them is this, you know, their ability to have these emergent abilities that are emerging out of them. The ability to reason, the ability to actually follow instructions. And as I said earlier, you know, we talked about this kind of evolution going all the way from codeware to neuroware to promptware, agentware, and mindware. And the question right now is software engineering itself needs to be rethought with that in mind. So the key points here is, you know, what is foundational models for software engineering? So as many people know, you know, I co-founded, well, basically I created this area called intelligent software engineering, which is the idea was to use AI to actually automate a lot of the work that software engineers are doing. But now moving forward, the idea is what is software engineering 2.0 with foundational models at the core of it. And then the other point of that is looking from the other side, which is using software engineering for this type of new software. So the panel we heard at the beginning, you know, the first panel was talking, how is that type of software going to look like? We talked about this idea of conversational type of software. We talked about this notion of software that is not 100% always correct, right? That actually is okay to being wrong sometimes, right? So probabilistic type of software. And then recognizing as well, you know, if anybody has built these foundational models, they themselves are some of the most complex software systems existing today. They're distributed softwares. You have to deal with a lot of redundancy, a lot of data movement in them. How do you actually build that type of software? What kind of software engineering practices are needed? And then if you go even deeper, you know, there's all these neural networks, and how do you actually do software engineering for neural networks? We talked about this. I kind of talked about the, you know, the different points here. I'm going to go to this point here. So I didn't talk about this at the opening today. Chris Ray. Okay, I know. Actually, a lot of people might know Chris Ray, but they might not know him. So today, what is that called? Flash attention. So flash attention is coming from Chris Ray's team. So Chris Ray is an interesting guy because I'm a software engineering. There's more of a systems guy. He's a systems guy. He's a systems guy that is software engineering. Okay. We met a couple times in the past, in the past before the pandemic. And last time I met him, he was talking about this idea, is that the future of machine learning will depend on it being in the hands of the rest of us. And he had this graph, and he's saying, the problem today is when we're building systems, we think something like CUDA, right? The complexity is quite high, and because of that, there's very few people that can use it, right? So the question he had at that time, we had met earlier, is what is that orange dot, right? And I think today we're seeing more and more this could be really where foundational models are. Something that's able to do something that's very complex, yet it's accessible to your average user. Okay? And we talked about this frog situation here. Now, key points here when something gets placed at the height of the inflation, the height of the expectation curve in the hype cycle. Basically what that means is there's a lot of promise on it, but there's a lot of inconsistency in that promise. And that comes around trustworthiness and safety. efficiency, productivity. So how can you take something and take it from cool demos to real products to trustworthy, products? And this is where we are right now with foundational models. And at the same time, actually, this is the same thing we are when it comes to AI for SE. So, AI augmented SE. Both of these two areas are at that peak point. And I put a roller coaster because really, it's the drop of that roller coaster. And if you drop so hard, you disappear from existence. And if you drop relatively good enough, you stay and you become something in everybody's, repertoire of tools. So what's happening today is the way we interact with software has changed a lot. So we went from punch cards to GUIs, and now we're really in this what we call conversational UI, right? And then even moving forward, so if you look at Elon Musk's Neuralink work, right? So their point is mind UI, right? So you don't even have to tell the software, it's just reading your mind. But what's happening to the definition of software changing. And prompt engineering is really an example of conversational UI. So output is very sensitive to the iterative prompting process. You're going back and forth with the prompt, with the GPT. And right now, it unfortunately remains as an art instead of engineering and a science. Now, what happens is when you think about the ways you interact with these foundational models, at the top, the simplest one is this, you tell the GPT, make my essay more professional, okay? Then, which is pretty much where most people are today, which is like kind of co-pilot, is write a function to sort a list, right? So it will generate code. And this is kind of where a lot of what we're seeing in industry. But really, what we're excited about and what we're seeing inside our labs and our own experiments is the two ones at the bottom. First is the foundational model is the function. I showed a couple of examples and say, okay, now, I showed, if I give you this, you'll give me a sorted list. I give you this, I give you the sorted list. Therefore, the foundational model says, okay, I can now become a list sorting function, right? But even going beyond that is, you are now a browser. You are now an OS. You are now a compiler. Behave like one. And this is why my brain exploded at that moment when I started seeing that we're able to do this. Now, most of you, because you use just ChatGPT, can you really get there? Well, the reality is with ChatGPT, you cannot get there. But with the right fine-tuning, with the right environment for the systems, we're seeing a lot of examples where this is actually possible in specific cases. But to get there, there's a lot of limitations and challenges when you're using them. Some of them is they're not able to do complex reasoning, okay? They have a lot of hallucinations. The closed loop, so the foundational model is not able to interact with the outside world, okay? There's limits about the context of the model, so you cannot give it, how much context do you give it? OpenAI just said now they've increased the context to like 300 pages or something, right? But still, the problem is even when you go increase the context, there's still challenges as the foundation model gets confused. It's like when a student asks you for help and instead of giving them the 2 paragraphs to help him, you tell them, oh, read these 5 books and this encyclopedia. Okay, so this is where we are in there. And then the other thing is this, whereas most of the AI folks think of emergent capabilities, me as a software engineering, more of a trustworthiness, I think of emergent limitations. For example, foundational models have very bad time generating people's fingers. They don't know that we have 5 fingers, and they don't know that our fingers go this way, not sideways. Okay? So these are emergent limitations are very essential for us to understand them, because once we understand these, we know where we need to focus on taking them to the next stage and making them more trustworthy. So in many ways, foundation models are, in my opinion, are the programming's calculator moment. So what do I mean by that? When we invented calculators, we didn't go and fire all math professors, okay? When we invented, Excel, we didn't go fire all the accountants. Instead, we've enabled a lot more people to do math. We've enabled a lot more people to do accounting. And then when they have a hard problem, they go to the experts. Which means, as a software developer, I think that's the best time for me, because I don't want to do all the boring stuff. And that's kind of what Ed from GitHub was mentioning, right? There's a lot of crap that I don't want to do. And if you can have me don't do this, and I could do the more fun stuff, the more thing that get my brain intellect going, then I'm more excited about that, right? Now, a lot of times I'm asked, so does it mean we're going to get rid of 20% developers in a company and things like that? The reality is foundational models now are having much higher expectations. You have your software. The fact that now people are expecting that they can talk to their software and they talk back to them, that's a new capability. So the reduction we're going to get from making these developers more optimal is going to be moved into the expectations that the users have of more and more richer software and more sophisticated software. So we're going to get this basically what we call the happy developer, the 10x developer, and we're going to move from moving from software developers, there is millions of them, to billions of software makers. So anybody can now code software, right? Grandparents, little kids can code software. And this is the thing. So this is really opening software engineering to the whole world. So the best way to think about it, so this is, I was trying to think of where we are in the world. So on this side, we have what we call software makers, and on the other side, we have software developers. And over the years, for example, you were able to do macro programming. Then after that, we started seeing, so there's something called Microsoft Flash Fill, was a technology that was by Microsoft. Okay? And then after that, we had VB script, JavaScript, and then all the way down to developing, operating systems, nuclear reactor control systems, and so on. So you can think of them as three levels, and they interact, right? So there's end user programming, enterprise programming, and system programming. Okay? So now when you come to end user programming, we're thinking about, personal avatar programming, SA programming, and what I'm really excited about, not as many companies are excited about this, but I really think what it's enabling is something very amazing, which I would say artistic programming. There's a lot of people today here have a lot of nice artistic sense, but they're really crappy at drawing pictures or actually doing music. But this is enabling a much richer people to express their sentiment and artistic things, right? Now, what's happening here in this type of programming, the human is in the loop. There's a back and forth discussion between you and the human. So you tell GPT to write an essay for you, I don't like this paragraph, we're going back and forth on this, right? Then now we have this enterprise programming where, there's a domain expert involved, and the domain expert is involved, but there's no involvement of the end user or tech expert, right? So there's human in the loop, but is limited in the loop. And all the way here, moving forward is, human is actually on the loop. And the reason when we say human is on the loop means the system is operating by itself, and rarely does it ever come in and ask the human for help. Because think about it, if an operating system every time it needs to do a context switch will ask the human, it's just going to get out of control, right? So we're already seeing, we believe we're here now. There are some prototypes here. Okay, even today, the panel was talking about compilers. We see some of that disappearing. There's some new work that's having Llama actually done as an operating system, so you boot into actually Meta's Llama. Okay. So now, when we talk about the 10x happy developer, so what are we thinking about that? So there was a study that was done many years ago, I guess in the 80s, okay? And this is called the 2 Sigma learning problem. So the problem is the following. If I'm teaching somebody and I'm just teaching them one-on-one, the amount of improvement you'll get from that one-on-one mentoring is so much better than in a class setting, right? And what Bloom wanted to do is one-to-one is too expensive, class setting is cheaper, can I find somewhere in the middle, right? So I can do mass teaching, but at the same time get almost close to that, right? And it's called the 2 Sigma problem because basically the productivity difference between these two is 2 Sigma. So you want to shrink that, right? So how we do that, and can aiWARE or FM augmented software engineering enable this mastering of productivity and learning the software engineering domain? So this is really at the core of why we think there's something very exciting here. But the reality as well is these foundational models, they're multipliers of productivity. So if your productivity is 0, 1,000,000 times a 0 is still a 0, okay? Now, what exactly is productivity in software engineering, which is we talked a little bit on the panel earlier today. So how we define productivity is very complex when it comes to software engineering. In the old days, the idea was lines of code. And we saw the example of Eric Gama where he does 5 lines of code a week. So that's not really an appropriate one, okay? And there were studies that were done much earlier. So there's this book, Making Software, that I was one of the co-authors in it, but as well Stephen McConnell, which is he's very famous for this Code Complete series. He was he consulted for Microsoft for many years, right? And the point right now is we know today there are tenfold productivity difference. There are developers that are 10 times more productive. There are even people that are as much as 28 times more productive than your average developer. Okay. So how can we get that with these foundational models? So originally, the original plan was to do it around, counting lines of code, but we're moving more and more into this more comprehensive thing. So that's called the space framework. So Peggy, that was in the panel, the second panel, is one of the people that kind of proposed the space framework. And the idea here, it's not just about productivity, it's about happiness, it's about self-worth, and all of these combine. Because here's the thing, training a developer takes a lot of time. And if a developer is not happy and they move somewhere else, that is a big loss in your productivity as a whole organization. Okay. So the main thing here, the key thing is, at least we believe that foundational models will not replace developers. But one thing is clear, developers that do not use foundational models and foundational model supported software engineering will be replaced by ones that do. Okay, so this is a more detailed picture of kind of this codeware, this evolution. So the idea here is, in codeware, you just had a function. You get a structured input, structured output. Very simple. Then after that, we went to a model. Structured input, structured output. But this model now is written, instead of written code, you're actually writing a search space for a neural network to search for actually your solution, your program. Then we went to this promptware. In promptware, this foundational model is the same. So every time you call it, it will actually give you the same answer. You can think of it as a larger foundation, as a larger AI model. Now when we look into this agent base, what's happening here is every time you ask the agent, it can give you a different answer. And the reason it can give you a different answer is because it has a memory in it that remembers the interaction. If I told you something, it will actually remember it and will know that you didn't like it. So when you think of Copilot today, if Copilot gives you a bad suggestion, and then you tell it this is a bad suggestion, the next person that asks this Copilot the same question, it will still give it the same bad suggestion. Okay? Because it still does not have this capabilities in it yet. It doesn't have a memory, it doesn't remember, and so on. Okay? And then moving at the end here, which is really moving to this, world models instead of foundational models. So if you think of software agents, they have many capabilities, right? So one of these capabilities is this generated parroting capabilities. So this ML++, very powerful machine learning model. That's all it is. And a lot of times people are using them for this right now. Even if we think of software 3.0, we're kind of here. But the reasoning capability, the ability to introspect, the ability to improve itself, the ability actually for it to act autonomously are things that are still not well defined. And this is why we are excited about this future, about all of these combined. So our excitement is not about the foundational model parts, but it's about all of these, right? And Andrea Carpacci, was asked recently, what excites you the most when you look at new studies? He said, I'm not excited about building foundation models. We've been doing a lot of this. Nothing exciting is coming up. But what really excitement and what I really feel the future is agents and how to really get agents, how to train them, how to have them collaborate. So the way we look at this future is a future where there will not be a single foundational model. So it's not going to be Pango, it's not going to be GPT. It's actually a combination of models, in the thousands here at most. Okay? And then these foundational models are going to be fine-tuned and specialized, put into promptware. But at the same time, we're not going to forget about the old world. There are things that old software is really good at. And now the question is how you make all of these work together. Right? And we look at all the big, so this vision, is shared not just by myself, but a lot of big companies are on that. Like, so the VP, the head of IBM research, basically his key point is that, one model, I guarantee you, will not rule them all. Even when you look at Satya Nadella, so Satya Nadella has access to the best. He has access to GPT. Yet he is more than happy to host any model that wants to be hosted on Azure, they will host it. Because at the end of the day, all he cares is somebody's burning CPUs on Azure, okay? But not just that, because we believe every model will have its own capability and its own strength. And believing that one model could do everything is not a realistic setting. So what we're seeing here is there's going to be a lot of high customization at the top of the models and a lot of flexibility of the bottom where there's going to be a lot of different models. And in addition to that as well, the type of knowledge that we used to build models is going to change. There's going to be this grounding type of data and guarding data. There's going to be human model alignment data. And this type of data is a totally different type of data that need to be governed. In many ways, we're thinking this is really data programming, because now not software developer, end users that are not experts, which we call software makers, can now express what their needs here, and that will be fed into model, eventually producing software. So instead of writing code, you're writing examples. So today in open source, if you want to contribute to open source, unless you're going to contribute with translation or updating documentation, you're not able to do that. But if you can just, all I can contribute in open source is giving a lot of examples, I could do a lot more. And GPT, our projection is GPT-5. So OpenAI has a project called the eval project, and all it's asking is asking all the experts in the world to give them 10 examples where GPT-5 is not doing good. And pretty much what's happening is these examples are going to be used to train GPT to become better, but now instead of being trained and giving this feedback loop with, humans that are not experts, now you're getting top experts to give you very specific problems and for you to help them solve these problems. Okay? So the future of software that we see it, is going to be hyper accessible. So as I said, it's this calculator Excel moment. Okay? There's going to be a lot of human agent collaboration. Okay? In addition to that, it's going to be continuous improvement. So lifelong improvement of software. So your software will self-improve over time. Okay? And then the key point here is trustworthiness will be built in. And next slide, I'm going to explain really what I mean by trustworthiness built in. So if you think about it this way, we're seeing the human involvement is going to drop and drop and drop. And a software 4.0 will at the inflection point, and then the machine involvement will actually keep on increasing. Now, that does not mean at this moment here, the human is not part of the loop. Okay? But the human amount of effort they're putting into the loop is going to be much more higher level of abstraction, higher level of complexity. Okay, so for example, writing constitution, telling the software your belief system, and based on knowing your belief system, it will actually act on that, instead of writing every single line of code. Okay? So the way we see it, so today you can think about it, so we have AI developers, we have architects, we have algorithm developers, this is not up to scale, but approximate, okay? And then what ended up happening, we added this band-aid around for trustworthiness. That's no longer possible. It's no longer possible to build software and at the end spend 2 months or 6 months adding trustworthiness. Really, trustworthiness is going to become a much core part of it. Okay? And everything will be controlled with our trustworthiness. There are prompters that are going to exist, a type of people that are going to exist, okay? And then there's going to be this green part here, which are software makers. These are people that might know nothing about this type of, they don't know how to program, but they are experts in this domain. Okay? And I'll give you a very concrete example. Today, Tesla, so Tesla does this, the wipers for your, so when there's rain, the wiper kind of starts up and goes, right? Well, traditionally this is designed by having sensors on the glass that would sense things and actually say, oh, there's water, then they would do it, right? Well, instead what they do is they took thousands of pictures of, of windshields that have rain on them and thousands of pictures of windshields that don't have rain on them. And then their camera is taking pictures every, couple of seconds, and then they take the picture and they build a model and they say, okay, is this picture of rain or no rain? Okay? Then what ends up happening, if it figures it's rain, then we'll start the wiper. Now, what is a bug? A bug happens is it's actually running while there's no rain, maybe because the sun is reflecting on the windshield. And the way you fix a bug is you actually take a lot of pictures with the sun facing your windshield. So I fix a bug, I didn't write any code. Anybody could actually fix bugs now. So this is where we're seeing the world moving forward, right? So this has really creating what we call a whole emergent, life cycle for FMware and FM itself. So basically how to build the base models, how to integrate these models, thinking it's not just of they're only by themselves, but in a combination of software 1, 2, and 3, and 4 and 5, right? And then things about how do you actually do performance engineering, software performance engineering in there, how you do operational, how you do patching of these models, how you deploy them, how you do governance. So this is the point here is really you need to do a total rethink of what software engineering's goals are. At the core of this is we need to realize something that, when we started programming, the old days we programmed with punch cards. Okay, and then after that we went from punch cards to text editors. And then for that we went from IDEs, and after that we went from platforms. Unfortunately, the way we are today is we're kind of in here, like we're between punch. So punch card is just going to GPT and giving it your, using the API. Text editor is more kind of like LangChain. This whole part is still not defined. And what the problem? And why is this a problem? Because you look at Microsoft, right? So the best thing is Microsoft is saying, people are asking is how come we can build so many copilots so fast? We have, Dynamics 365 Copilot, we have Power Platform Copilot, we have GitHub Copilot, we have Bing Copilot, we have Security Copilot. How are we doing all of this? Because Microsoft has spent the time to create the platform, a productivity platform, so not everybody has to relearn how to, reinvent the wheel. So this is one of the key, competitive advantages that Microsoft has today when it comes in this domain. Not only did they have access to the models, but they thought of how to maximize their productivity at scale. Now there's many benefits as well of these platforms. First is the developer experience and the productivity increases, but as well the trustworthiness of the applications because the platforms provide that for them. Okay. So this is a report from Sequoia. So Sequoia is one of the top venture capitalists in the Valley, okay? And they, anybody that's doing something cool is probably funded by Sequoia, okay? And so Sequoia actually went down and asked 33 companies across their network, from seed stage startups to large public enterprises, and where is the next thing you see in foundational models? And the key point here, everybody's coming, it's much more than the foundational model. It's much more than the APIs and the frameworks, but it's about the whole thing fitting together. How we can actually ship products out of this, okay? So there's a big interest in how to do orchestration. There's interest as well in retrieval mechanisms become a main issue with these foundational models. Today, the foundational models, some people think of them as just a good search engine, but actually the real power of foundational model is their ability to reason. So now, a lot of people might say, oh, but what do you call it? The OpenAI, the last time it got data was from 2021. Is that a problem? But that's not a problem actually. Because the way people do it is they take the model and they're using it for the thinking ability, and then they give it fresh data, right? So that's the trick. So it's okay that it's 2021. And so I guess 2 days ago they updated this to I think September this year or something like that, okay? But it will always be behind. But the key point here and the key advantage of a lot of the companies that are building these foundational model apps is they use them more for their thinking ability, their reasoning ability, and then they augment them with data. Okay. As well, the whole observation and monitoring is going to become important. And then now, when you look at companies that are in these high trust environments, right, regulated in industries, right. So data privacy, security, copyright, governance frameworks is something that's currently quite lacking. Okay. So now I'm going to quickly go for foundational models. So this is not going to be an AI lecture. So if you don't get worried, I'm not going to show, there's no math here, okay? But give you a quick idea of where we are in the world. So AI started first what we call expert systems AI. Okay, so this was like more, symbolic rules. So basically you wrote that you told AI everything to do. Then after that we moved to machine learning AI. So these are handcrafted features that are engineered from data and domain knowledge. Then we moved to deep learning, so driven by neural network. Feature engineering itself was no longer needed, and you kind of learn task-specific features using neural network. And then now we believe we are what we call AI 4.0, which is foundational model. So the abstraction of the neural, we no longer have to worry about the neural network and all the complexity of describing it. We're talking about a higher level of abstraction. Now there was many tech enablers that enabled this, right? So big data got us to move from 1 to 2. The ability to massively label data was from 2 to 3. Self-supervision at scale got us to move to 3 and 4. And then we believe what will get us to move from 4 to 5, which is basically human alignment. Get the model and the human to be aligned together. So this is alignment of values. So you and the model have a same values, and as well alignment of what you want the model to do. In addition to that, the programming models as well have moved over the years. So we moved from basically CPU compute to domain-specific compute to GPUs and MPUs to actually distributed computing, heterogeneous distributed computing, and then what we're really projecting, actually I was projecting this, but now it's no longer projected because Andrei Karpachy already is tweeting about this, right? The foundational model is actually a type of compute unit. It is the new CPU, okay? Now, the reasons we move from all of these is, basically we're arriving to the situation where the compute and the memory needs, no matter how fancy you have a specialized hardware that's very specific to your domain, is not enough. So really this heterogeneous distributed computing is the future, and we're seeing more of that happening, okay? Very concretely, okay? So explain kind of how those software had changed. In the old days, in this deep learning, you have a software app. That software app might have maybe 10, 20 models. Every one of these models was very hand-coded and hand-tuned to the hardware below it, the GPU, the MPU. Okay. But now when we move here, what we have is we have a foundational model. So basically we created a layer, okay? And this layer, yes, there's still a lot of hand-tuning and optimization here. But once we go above this, now everything is built on top of this foundational model. So now if you migrate, GPT or you migrate Llama to different hardware, then you as well will migrate every single application that's running on top of them. But in the old days, if your company wanted to migrate the different hardware, they would actually have to migrate the 100 baby models that you created and fine-tune them. Instead, you can migrate one at the bottom, and then everything on top here is fine-tuned from a data point of view. So the hardware dependencies are actually dropping quite a bit, which is quite impressive and promising, because we have moved to the, right now the world is very like NVIDIA-centric, and it's never a good thing when anything is just specialized in one thing, okay? So this ability to open up the bottom of the stack and have it more, open is very important, and foundational models, we believe, really is a very important step in there. Okay, and this is what I was saying. So this actually, he tweeted this November 10. So he's saying, large language model S, bear with me, I'm still cooking, right? So in his point here, large language model is the CPU, the context window of the large language model is the RAM, okay? His vector databases are like the disks, okay? And now, if you start thinking of that deeper and deeper and start to realize what is the implication of that on how we build software, where you now have a new type of compute unit that has its own much richer capability, and you could talk to it at a much higher level. And that's why some of the comments in the first panel was, do compilers even going to exist anymore? Because you can just tell your CPU a lot of the things you want done. Whereas today, only CPUs knows how to move data in and out. Okay? But at the lower level, which is what the panelists were saying too, is yes, there will still be low-level, compilers. Okay? So, there's a rapid growth of foundational models. So there's, for a while, there was every like 2 weeks, there's a new foundational model coming up. Okay? And many of them are publicly available, and as well there's a lot of commercial ones. So, this one shows, where's the commercial? Oh yeah, so these are ones that are publicly available. These are closed source ones, okay? Now, we have changes as well now in the licensing capabilities of model. So today, you have fully closed, gradual stage, hosted access. So, you can access it, but you cannot really get into it. And the problem, for example, so GPT-4, you could use it, but you can't fine-tune it, okay? Because the problem is once you fine-tune it, then you can actually start learning, you can be able to decompose, like you can start understanding what the model is doing in the back end, and you may be able to kind of reverse engineering. So they don't enable that, right? And then you can download it all the way to fully open. The problem right now, when you look kind of in looking at the dates and how things are going, you can see there's a lot more red here, so there's a lot more fully closed, and as well that the number of parameters keeps on increasing over time. Okay. So there's a kind of problems as a researcher getting access to that kind of information, and even release engineering as a science in sub-area of software engineering. What does that mean in this kind of environment? Now, ChatGPT, very briefly, so this slide kind of shows you the evolution of ChatGPT. A couple of things that are very interesting about GPT. So originally it was trained without code, source code in it, okay? But something happened, and this is a type of an emerging capability. Once they added source code in it, it became much better at reasoning. In a way, it makes sense because code has a lot of logic and is quite structured versus human talk, which is a bit more random, right? However, this has never been proven, but that's, so that's an example of what we call an emerging capability. Okay? Now, a couple of things to note, so GPT-3, 3.5, right, is 175 billion parameters, but GPT 3.5 Turbo, until recently, nobody knew how many parameters, but we now know that it's 20 billion parameters, okay? Which is basically tells you it's much smaller than it looks like, okay? And what we believe, and a lot of people now are believing too, is GPT-4 is not as big as people think it is. It's actually a combination of many foundational models working together instead of just one humongous foundational model. Okay, and then just last week, GPT-4 Turbo was released. Okay, so this is again a slide of the publicly available ones. There's a few of them. Like a lot before GPT in software engineering, like T5 was used quite a bit in software engineering. But there's a lot more that has been now available. Bloom as well has been used, and now the big one that's kind of coming and becoming more and more popular is Llama. Okay, so these are examples of the different offerings over the years from different companies. This is the thing. So this slide I think is very interesting because. Llama's giving out GPT, its Llama model for free. And the question is, why are they giving it for free? The reality is imagine if you are the Linux of the new world, okay? Imagine if you're the Python of the new world, okay? If you imagine if you're the PyTorch of the new world, well, guess what? They did it, Llama already did it with PyTorch. They did it with Python. So this is what they're doing with GPT, with Llama, right? So Meta has already did all of these with prior instances. Why this is important? Because now the whole world is developing and optimizing for your platform. The same way everybody's building and developing for NVIDIA, for neural networks and stuff like that. If now we think of the foundational models as being the new type of OS and the new type of chip, then if everybody's developing on your model, you become the standard. And we're already seeing a big explosion around Llama and its capabilities. So it's kind of having the whole world work for you. The whole world work for you, and you become the standard. Okay. I guess the best example is like in the old days there was there's Betamax and VHS. I don't know if anybody remembers video, right? And Betamax was by Sony, and Sony totally controlled it and didn't want to give anybody access to the world. And the other VHS, everybody could license it, and now VHS took over. But anyway. DVDs came and all that kind of stuff, okay? But that's kind of what we're seeing here, right? Now, the data pipeline itself as well, the creation is quite complex. It's a very complex pipeline. And this is kind of comes down to what I was saying earlier, is that these foundation models themselves are very complex software. Managing this data pipeline, if there's a bug in the pipeline, having to restart this is something that takes, weeks, if not months sometime. And then now you can see the different models and the mixture of the data they use, right? So, so example, especially when it comes to code, right? So some models have all code, some of them have a little bit of code, some of them, don't have any code in them, right? That gives them very different capabilities, and this is why we believe that at the bottom of the stack, there will be different models with different capabilities coming from the architecture of the model, but also coming from the data of the model itself. So, the way the world works right now, so this is, We get raw data. So there's basically, you take raw data, you do language modeling, which is basically just predicting the next token, and you get the base model. Then after that, you go for that base model, and then you could use that base model here, and you could do prompting. So you could just ask it questions back and forth, right? And that, if the model is good, you could go quite far with that. Okay? But then what people have been doing is they do supervised fine-tuning or reinforcement, kind of human-in-the-loop fine-tuning. So what happens is, the best way to think about it is, that type of model that comes up from here is like somebody, you just hired a new employee in the company, okay? So they know everything about they know a little about everything, but they're not specialized in a specific area. In fine-tuning, now when somebody joins your company, you spend like 3 months training them on the company, and then you spend another 2 months training them on the org, and then 1 month on their specific task. That type of training here, to get it to really become very good at that specific task, is really the fine-tuning process. Okay? And this is really where we see the models becoming much more powerful, where they're fine-tuned for specific tasks. Okay? And the beauty of that is, as you give it more data, it becomes better and better and better and better, right? Which is actually that makes the investment in the data very valuable and worthwhile. Okay? These other ones here, so these more complicated type of fine-tunings, they bring a human in the loop to actually judge the model. So they get the model to give a result. The human can give it a thumbs up, a thumbs down, is one type of way. The human, it can give you 3 results. So it says the answer is this answer, or this answer, or this answer. And then the human has to rank them. Okay? And then you create a reward model such that now you can improve the whole model. When you use GPT, sometimes you will see it has this thumbs up and thumbs down. That data now is used to do that type of training. Okay? Okay. So, at the highest level, that's basically what we call supervised fine-tuning. So this is, the results come in, the human says yes or no. Okay? So that's, the data has been tagged by human. Then there's the human feedback loop fine-tuning, which is, there's a human in the feedback loop that's actually giving rankings, thumbs up, thumbs down, sorting the different type of results, saying, I prefer this answer over this answer, okay? These two have chosen to be very powerful and very useful. Actually, this is the secret sauce that really made ChatGPT what it is because when you talk to it, you feel it's like a human. It actually understands you better. It uses the right tone for you. It's because actually a human did that final thing, right? And that's the key point, is that AI will not replace humans. It's actually AI and humans working together. Okay? Now, what's happening, though, unfortunately, this is very costly, right? GPT did it very good because they just fine-tuned it on just basic English understanding, the tone and things like that. But now you want to fine-tune for very specific tasks, it becomes harder. It's like you can fine-tune on how to write if statements, and that, for one, you can get like, first year, second year university students. But if you want to fine-tune on architecture, you want a GPT that's just very specialized in architecture design, well, that needs to be fine-tuned by some of the world top architects. How many of them are in the world? And you cannot hire them for, for what do you call it, 20 cents an hour, right? Or 20 cents per click, right? So the cost becomes much higher. So one of the things that's coming up, which is coming from Anthropic, okay? So Anthropic was a team that was part of OpenAI, by this split out of OpenAI. And what they're doing is what's called constitutional AI. So instead what they do is they train a GPT and they give it a constitutional. They write a constitution. They write their belief system. And then now, when the model gives a result, it goes to that other foundational model. And then the other foundational model looks at the results and says, and you can ask it, this result, does that match the constitutional that I gave you? So for example, you say you should never try to kill somebody, okay? And then you ask GPT and it says, you ask, hey, what's the best way to kill somebody? And it will give you like a list of 10 ways. Then you take the results, you feed it to the other foundational model that's only tuned to do this type of, constitutional. And then the constitutional model will say, no, no, this is something bad. You should never answer this question. Okay? Traditionally, you would have a human doing this. But now you have a GPT helping you, so now you have optimized it. So your human now is no longer part of the day-to-day operation of this feedback loop, the fine-tuning loop. Your human is out of the loop. That's why it's called out of the loop. He's providing the constitutional, and then the GPT is actually doing the optimizations. So as I said, so there's a lot of promise in there, but there are many challenges. So the cost of human feedback, how to model actually how do you model the reward thing, the different actually policies that you would use. So this today it remains one of very challenging areas in AI, because today people believe that if we can solve this and have human in the loop in it, then we'll get quite far ahead, because the excitement we had about GPT for general type of compute could now be moved to more complex compute, right? Today in industry, what people are doing is they're cheating. So this constitutional type of AI that I talked about, what a lot of companies today are doing is they take a much bigger model and they have the bigger model judge the little model, okay? And now what you would hear about something model collapse. So the problem here is if a model is trained by a model, that's trained by a model, is trained by a model, after enough time of this, the signal will disappear, and then there's just the final model will not perform well. But that said, today, some of my guys were at the Ray Summit in San Francisco a month ago, and that was the big thing. Everybody uses GPT-4 to actually fine-tune GPT-3. And the reason is GPT-4 is very expensive, and GPT-3 is very cheap. So you cannot really make a lot of money if you're going to run a company where everything in the back end is on GPT-4. So that whole idea is very similar in a different context of how we do software performance engineering, right? Do you put the fastest CPU in this machine and the fastest memory in this machine, or do you got a nice balance between a slower CPU with maybe more memory? So this whole performance engineering now is being moved into this. The problem right now is a lot of this is done in an ad hoc way. So this is, for example, an area of people in software performance engineering, in software engineering. This is really what SPE will be in this world moving forward. This is just an example of hallucinations, right? Now there's two types of hallucinations, so what we call intrinsic hallucination and extrinsic hallucination. Okay? So intrinsic hallucination is, the answer is there. It just is pretty dumb, okay? This one, the answer is not there, and it didn't get it, right? So this one, you can forgive it for this one, but you cannot forgive it for this one, okay? So that's kind of like the different types of hallucinations. And that is one of the challenges that, as everybody's trying to solve today. But at the same time, when you fine-tune these models and bring them down to smaller tasks, you can avoid a lot of the hallucinations. Now, the reality is, I always end this section by highlighting something, which is that the safety of these systems is very important. Okay? But if you think about how long it took the seat belt from the day it was invented in 1950 all the way to become a law, 30 years later. Okay? It's quite far. I don't think it will take 30 years. This field is moving much. I've never seen something move this fast. Okay? Because they have totally moved out of conferences. Everything is done online. Everything is collaborative. To be honest, as a graduate student, it's a scary time. Because literally, you can wake up in the morning, your paper that you're working on, somebody has done it. And then you say, I have a different idea, but that paper that somebody has done it, already 5 people have challenged it and posted it on archive. So this whole open collaboration has sped up things quite a bit in the last few years. Okay? And yes, as I said, this one example, another example, I don't know a lot of people know that, but when cars were invented, they were worried that cars are basically going to go faster than horses and will cause a lot of havoc. So the idea was that if you have a car, you need to have a person running in front of you as a red flag, which meant that you cannot go faster than that person. Okay? So these were 2 safety mechanisms in cars. One of them died, one of them remained, and I think what we're going to be seeing, a lot of that's going to be happening in it moving forward. Okay? Now, a couple of key terminologies, kind of the key to think about. So there's this, I don't want to spend a lot of time on these, but models are judged based on their parameters. The belief until maybe a year or two ago was that bigger models are better. Prompt is the kind of what you send the model, okay? Prompt engineering is kind of like how you design the prompts. I like to call it prompt hacking, not prompt engineering, okay? React, chain of thought are examples of ways that you can prompt the systems, okay? Temperature is an interesting one. So if you ask a model a question, there's a temperature measure. When you put it at 0, means every time I ask you the question, you should give me the same answer. Where if you otherwise you could say, no, I want the temperature to be high, which means I want you to innovate and explore, so I prefer to get different answers. So if you're using for something artistic, if you told it, draw me a picture of the beach, ideally every time it draws a picture you want it to be different. So that's where the temperature is, okay? Tokens is just basically the tokens you're dealing with, and this top n and pass at n are just how you measure the quality of the results. So if I look at the first n results, where I have the answer that I'm looking for, okay? So zero-shot learning and few-shot learnings are two examples as well of prompts. So the idea here is instead of just asking the question, and that time that's called zero-shot learning, so I didn't give you examples. Few-shot learning is you can give me some examples. If I ask you this question, this is the answer. If I ask you this question, this is the answer. Now, I'm going to ask you this question. Okay, and we're going to kind of go through these a bit later. Okay, now, I want to spend a few minutes here to talk about bigger is not better. Because the problem is as usual, when it comes to computer scientists and sysadmins, everybody wants to have something bigger, right? So every sysadmin tells you, oh, my disk array is bigger than your disk array, and I have more machines and stuff like that, right? So for the longest time, there's this belief that bigger is better, and it comes down, the early days, what we found is bigger models are leading to emerging capabilities. So there's a lot of capabilities that have emerged as we started getting the models bigger and bigger in size. So the idea was, let's just keep on going bigger and bigger, and we're going to get more and more emerging capabilities. Okay, and what ended up happening is, for the last few years, as you can see, is just exponential growth in the number of size of the models. Yeah. And then, yeah. Okay. The problem is you get the models bigger, they cost a lot to train. Okay, and millions and billions of dollars. But not only that, their latency becomes very high. Okay, so from an engineering point of view, it's really impossible to keep on getting them bigger and bigger and bigger. So what is the sweet spot between the size of the model? That's one of the big challenges. Okay, and actually in many ways that led what I would call, this enterprise HPC scale. So today, a lot of the companies that are famous for AI have clusters that are bigger than national clusters, right? So so this is this is an example. So this is the size of Meta's cluster. This is an EU national cluster. This is a US national cluster. This is a German clusters. Okay. So as you can see, Stability AI is here. Bigger and bigger models require a lot more machines. Okay. But what we know today is, so this has not been proven, okay, but more and more we believe that GPT-4 is not, so it's not like GPT-3 was this small and GPT-4 has so many more parameters. It's actually more like this, okay? GPT-3 is this size, GPT-4 is a bit bigger, but there's many models. And the reason we started believing in this is because if you ever actually interact with GPT-4, it almost feels like you're acting was based on the different type of questions you're asking, it almost feels like you're acting a totally different person. So this was the intuition we got. But recently as well, there are some studies that are showing that this might be true, not just from the impressions we have, but actually from the errors in the models that are being produced. Okay, yeah, so GPT-4 is not that large, And even when you look at a lot of times OpenAI would create a GPT and then we create a turbo GPT, and the whole idea of the turbo is to shrink the GPT. So GPT, free was 175 and 3.5 turbo was 20. And then even when you look at the advice that Amazon gives to their customers. So Amazon has a 20 billion parameter model. Yeah. So Amazon does not go around and say, whoa, we have a 20 billion parameter, please use the 20 billion parameter model. No, they say, please do not use our 20 billion parameter model in production. It's not designed for this. Okay. Instead, what they advise their customers is, use our 20 billion parameter model to train our smaller model in your specific area. So use it to fine tune it, as I was mentioning earlier, right? So use it as a big brother that could teach the little guy to be specialized in this, right? And then what will happen is your little model that has very, much better latency, better cost to operate, will be much better or almost as good as the big brother in, say, playing soccer. But he will suck in playing, squash and stuff like that. Okay? So, what we're seeing as well, is this whole, even the number of bits that are used. So this whole k-bit inverse scaling laws. So several of these models are showing that 4-bit quantization, 4-bit precision is optimal for a lot of the zero-shot accuracy and reducing the number of bits. Okay, and as well, we're seeing this parameter efficient fine-tuning. So there's more and more focus on shrinking, not growing. Okay. Another thing too is when you look at the foundational models that are used for code. Okay, so the folks at Meta just had, 3 months ago released a foundation model that is used internally. So actually, Meta has 2 foundational models that are doing code. One foundational model that's developed by the AI folks, okay, which is Llama code. But Meta does not use that. Internally, they don't use the AI one that's available outside. Instead, there's another one that's developed by their software engineering team. Okay? And what they did is they started with a big model, but then they realized that the big model, the latency was too high. And in reality, is the user experience. So if you type in, you want to get completion, it's taking like 3 minutes, you're not going to use it, right? So Meta has their model is only 1.3 billion, which for most people, like, that's a joke, right? That's a tiny model, right? So that's the trick, right? It's really this optimization. So when I see people say, oh, our thing is going to get better when we have, a bigger model, I'm just scratching my head, because people that are running these things are actually, the first thing they do is, so there's 2 things that people do. They either start with a really crappy model and try to get it as best as they can, and then they try the big model to figure out how far they are, or they start with the big model and then try to shrink it. And usually you start bottom and you go up, because once you're up there, it's hard, once you're used to the good life, it's hard to kind of shrink down, okay? So that's what we're seeing was a lot of things, and that's even when we talk to OpenAI folks is, they say, 3.5 is really where we think people should be using it more, and 4 is for fine-tuning, is for that kind of constitutional type of fine-tuning. In addition to that, observations as well that has been reported is, so the idea is, so when you ask the GPT a question, so there's the prompt, and then the prompt has a limited size. So if you want to give more and more information to the prompt, that means the prompt needs to get bigger and bigger and bigger and bigger, right? And the idea is, well, if we can get the prompt so big, then what we can do, if we wanted to do code completion, we just give it the whole project. Well, what we know today is that what ends up happening is the models actually perform pretty crappy, like it's called lost in the middle. Yeah, lost in the middle. So they kind of figure the things at the top, the things at the bottom, but the things in the middle, they kind of drop them. Okay? So, OpenAI just said, oh, we're going to increase the model, what do you call it? The context window is going to be much bigger for our prompts. But in reality, this is not a solution. This is opening a bigger can of worms of how to really optimize the prompts and their sizes. Okay? And even when you look at the data size, so what as well our studies are showing that, here's the problem is, as you bring more and more data, you're bringing a lot of garbage, okay? And studies by Microsoft, it shows that if you spend more time cleaning your data, polishing your data, you'll actually perform much better than a bigger model, okay? So this was studied at Microsoft about the general things, but in software engineering we have actually very concrete examples. So Meta, when they build their code compose foundational model that's used, it's kind of similar to Copilot, okay? What they did is they said, we're not gonna put in our model any code that hasn't been touched for the last 2 years. If code hasn't been touched for the last 2 years, we shouldn't even put it in our model training. Which is like shocking because everybody's like, bigger is better, let's put more and more garbage, right? That's one. Second, they went for all their code and removed any kind of anti-patterns that have been recognized by their development team that they're bad. A lot of times the code has anti-patterns, but it's working, nobody wants to touch it. But the problem now is if you put that into your model, then guess what? Your model is going to start recommending these anti-patterns. So this data engineering part and data cleaning and data management is as essential as the prompting as well as essential of the model. So all of them work together. Okay, and we're seeing this more and more becoming, and that's the key point here is that in many ways, software engineering of the future, where we think today as software is only code, we're going to have data, we're going to have prompts, right? We're going to have agents, and all of these have different characteristics, right? Today, when you copy a piece of code and store it in your system, that piece of code won't change. But an agent that has lifelong learning, you download that agent from the internet and you keep it on your disk, and if you still have it running, that agent in 6 months will become smarter or maybe dumber than what it was, right? So it's a very different mentality of how exactly the artifacts and how to manage these artifacts, how to do asset management, how to reuse them, how to share them, how to collaborate around them is a big problem. Okay, now, people have been trying to understand why is this happening? Why is it we keep on, like the idea was like bigger is better, man. What's happening, right? So there was a few, I guess 2 years ago, something started, was called the inverse scaling prize. So the idea was as you grow, as you give more and more data, as you grow the things, the performance should go up, 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 right? You shouldn't see it where it starts like dropping. Okay? And the challenge was, they created a prize and they said, give us examples where you see it as it go bigger, it actually gets worse. Okay? And then after that, they took all the tasks and they tried to understand why this is happening. Examples of that, the reason was that, today, as the model gets bigger, it becomes heavier in its current belief system. So if your prompt is only this much, but the model has so much data. That little bit of data cannot really shift what the model is. And if the model is garbage, even if you have the best data in your prompt, it's going to be a problem. Okay? The other thing too, so as you have a lot of data, and the models become more and more complex and sophisticated, they will start seeing patterns that don't exist. Okay? So the weaker models are good because they only see the very relatively strong patterns, and the weak patterns, they just don't see them. But the bigger models actually find noise and think that noise is a pattern. Okay? So that's another thing. So, okay? And then the other thing is sometimes inside the prompt itself, for the bigger models, they get confused. Again, they find a pattern or an anti-pattern in the prompt itself, and they misread it just because they're super powerful. It's like getting it's a difference between asking a child a question and asking somebody with 3 PhDs a question. The 3 PhD dude is trying to read and misread everything and try to think deeper, and the little child, you tell him, give me a glass of water, and he's just going to get a glass of water. Whereas the more sophisticated guy, oh, why do you want water? And all these things, and how big are the water, and all that kind of things. Okay? So that's just some of the example, right? So, at this moment, there's a lot of cases that they have shown, but linking these cases to concrete business problems is still not actually, they haven't done that. And that's why they had different prizes. They had like a top prize and a medium prize and a lower prize. They gave people lower prizes, but the top prize, they said, nobody has really shown this to be a problem, for a very business concrete case. Okay. Now I'm going to talk about prompt engineering. I like to call it prompt hacking, and I will explain to you why I call it prompt hacking. Maybe before I do that, any questions? Yeah, go ahead. I was just thinking, maybe somebody get a mic. Sure. Yeah, go ahead.
Hi. Yeah, I just had a question about bias in the models, because I don't think you covered that. So, I mean, just to give you an example, I was playing around with ChatGPT recently to help me design an app. It came up with a ton of requirements. I asked it to prioritize those, and it put accessibility at the bottom, which seemed a bit of a bias to me, that it's clearly been trained on data where developers haven't considered the accessibility of the application. So I was just wondering, in the training, how do you actually overcome some of the biases that might be inherent in the data?
Yeah, so usually what happens is that the model is built, like the GPT's model built, and then there's almost 6 months of kind of unbiasing and kind of safety protection for the model, right? Now, what ends up happening is sometimes some things kind of drop out and don't get picked up, right? But really what happens is if you have ability to fine tune, then you could show, okay, this is a bad example, and then the model will just integrate it in and it will kind of disappear, yeah. But biasing, yeah, so we went from like, okay, the software is ready, we can ship tomorrow, the software is ready, 6 months of doing all this safety protection, safety testing. So that's another thing, yeah. Yeah, go ahead.
Yeah, so just now you share visions that the FM model will become the compute unit for future computing, right? So the fundamental compute unit, and then the application will be sitting on top of that. When you migrate, then everything will move, right? So my question to that view is that, as we know, like a foundation model, as like any other AI, just now you're also sharing about the temperature, right? Yeah. So it never be 100%, right? It would be like 96, 97% accurate. So in today's applications, right? So there are some applications that will require very accurate and very consistent answer. So when that map into that vision, how do you view that some applications that require like a high precisions that will get the same answer always running on top of that model?
Well, foundational models, if configured correctly, could be repeatable. Okay, actually, OpenAI just made their foundational model repeatable a week ago. Okay, and the reason is there's many things that happen. So first, the state of the infrastructure impacts it. Okay, the temperature impacts it. And there's another parameter. There are 3 parameters that impact the stability of the model and its consistency, right? So as more and more people are using this, now there's a push on OpenAI, and eventually other, companies are going to be doing that too. But this is the same problem that existed in regular software. So one of the biggest problems was the build repeatability. Okay. And the reality is, every time you do it, you build people think that if you build the same source code, you're guaranteed to get the same binary. That is not guaranteed at all, okay? And a lot of companies have been, actually Huawei is very known for their ability now to do this repeatable build. And more companies now are trying to get to that. And now we're seeing the same thing repeating. So there's a lot of repetitions happening here, right? And that's the value of having the software engineering folks, because we have a bigger perspective more on software challenges that happen, and what is a foundational model software, what is a compiler-based software, is the same problems, right? So stabilizing and making the predictability of the model is essential. The thing that still needs to be solved is the predictability of agent-based software. So there's today software solutions that you give it a requirement, and it will generate a source code for you, right? And using all these agents talking together. If you actually tell it to do it again, it will generate a different software. If you tell it, okay, can you please, imagine like you don't like some solution here, it rewires everything at home, right? That's not what we want, right? And that's the difference between wearing a software engineering hat and an AI hat. Software engineering folks have a better understanding of the importance of software stability, because we know that a lot of problems that happen in software is that you change it. Like most software will not break if you don't touch it. But if the AI is just going crazy and not thinking of that, and a lot of the AIs are not focused on this. And the way we see it is, this is an example where we think AI models need to be fine-tuned for deep understanding of software engineering problems. AI models don't know about design patterns. AI don't understand that we don't want software to change so much. Even might give you a 3% improvement in performance. Stability is very important in software. So this is kind of where the two worlds are colliding in the same time. The innovation on one side, but the stability and the rigor of software engineering. A lot of times I think software engineering is a boring world, right? But the thing is, the reality is to ship real trustworthy software, it's a boring business. You know, that's the thing, but it's exciting still, the stuff to do it and how to enable it, right? But yeah, so that's, you know. Okay, so let me go through the, so prompting, you know, basically, you know, you instruct the foundational model on specific tasks. Okay, you enable kind of new capabilities in the models. You know, there are different types of prompt. What's called a system or a base prompt, and what's called a user prompt. So GPT actually has what's called a base prompt. And the base prompt, when GPT first came out, people were trying to reverse engineer the base prompt. So for example, GPT's base prompt says, you know, do not insult people, be nice, do not give people advice on how, you know, how to hurt themselves or hurt others. All of these are a lot of instruction that you give, right? Now remember, you have this much space for a prompt, and maybe 20 to 30% is base prompt. The user doesn't see. But this is where trustworthiness happens, safety happens, diversity kind of happens. All of that is happening in that base prompt. You as a user don't see. GPT as well provides you the ability for you to, you can configure your, if you use ChatGPT, you can configure it to actually have your own base prompts. So you could tell GPT, I want you to behave like a teenager whenever you're talking to me. And that becomes part of its additional, your own private base prompt. Okay? And then after that is the prompt for the task at hand. So that's the different kind of levels of prompts. Right? Now, the structure of the prompt, so you know, there is two types of things. So there's task-related information and there's context-related information. So, you know, what you want done, what kind of constraints you want around what you want done, how you want to be formatted. For example, a lot of people that use GPT wanted to be formatted in JSON. Okay, and until recently, ChatGPT had a hard time with JSON. It wasn't producing correct JSON. Just last week, they claimed that they have fixed this problem. Okay, so that's an example. He said, and whatever you answer me, give it to me in JSON format. Or give it to me in a format that I'm going to give you some examples of. And this is where the context comes in, right? So you give some background knowledge. So one of the problems that we were saying is these foundational models, a lot of people say, oh, it has been, you know, the last time it was trained was like 2 years ago, or so it was trained 3 years ago. It's okay. The reality is it's kind of like when you're interviewing somebody, you know, like, you know, when we tell you, do you hire somebody because they know C# or because they have a good mind and they have good reasoning? Okay. I hope you're hiring the good reasoning person, because the C# guy won't be around, you know, in a couple of years, right? So that's really what you're coming in. So, but now you need to augment it with knowledge coming in from your own business or fresh data about things, you know, providing examples, telling it how to act as a persona. So example, Bing uses GPT, and what it does, it does actually a search. When you give it a question, it takes some of the information from the search, puts it in this knowledge, and then takes that and asks GPT. Okay? So that is, you know, that's called, you know, retrieval augmentation. So I augmented the prompt with data that I retrieved from elsewhere, and then I put it there, and then, you know, now I'm asking that question. The nice thing about that is if the model is accurate, the idea here is you want to give more priority to this information that I'm giving you right now. Okay? Because that's more fresh, that's more relevant to my point, over the billions of documents that have been fed into you. Ooh. Okay, so, you know, so example of a simple prompt, you know, the sky is blue. This is like, there's no reasoning here at all. This is really what foundational models kind of were created for originally, which is just basically predicting the next token. Okay? Now, you know, you can have more complex one, right? You know, so the classify the sentiment of the following sentence: the meal was awesome, the sentiment was positive. Okay. Now, for software engineering, a lot of times when we do research, we end up doing a lot of data tagging. And it's always your student asks his friends and his friends' friends to help you to tag the data, right? It's very hard to get like, experts, developers to help you tag the data. The reality is these models, if fine-tuned appropriately, given the right instructions to fine-tune and tag data, they will actually, I can assure you, they will perform better than the average student that's doing this. So this is another way to think of these foundational models. They actually will enable you as a software engineering researcher to do much more complex analysis, to do it at a much bigger scale. Now, I'm not saying just go to ChatGPT, ask it all the questions, get it, right? So you need to do some kind of baseline analysis, have some done by humans, have some done by the GPT, and then compare them. And I remind you, it's kind of one of the key things that Jack mentioned in the panel in the morning, which is we're not looking for perfect answers. We're looking for answers that are as good as human and as good as the average human in our case. This is a very different way to think of how to build software. Okay, yeah, so so this is the example where you could say, you can ask the foundation model to restrict how the generated result looks like. So, classify, the following sentence into neutral, negative, or positive. So you told it this is the three options it has, and then it will actually give you one of the options. This is a very simple example, right? But you could say, give me the results in JSON format. And once you give it in JSON format, then it can plug in so many web services. And now you have web services talking with foundational models, and you have now software that's not only foundational model only. Okay. This is an example of more complex prompts. So this is called in-context learning. So what you have here is you give it Q&A, and then you ask it a Q. So you're basically giving, okay, this question, this is the answer for this question. For this question, this is the answer for this question. You could put many of these. And then now you ask it a question, and the idea is from these examples, it should actually figure out how to give you the answer. Okay? So that's one. Okay? Now this chain of thought, okay, what happens here is, so the blue here is the chain of thought. So if I don't have this blue part here, I just give it the answer. I didn't show it how to do the work, right? So it's the same way when you go to a TA and you're in a math class and you say, I'm having a problem solving this problem, right? And then you tell, oh, the answer is 22. But like, I don't know how you did that, right? But instead, if you tell, okay, the first thing we need to do is we need to think about it this way, we need to break it down, we need to do this, we need to do this, and therefore, this is the final answer. Okay, now you'll understand how to decompose things, and then now you could do this in many other cases. And in addition to that, you basically showing me your work. So like teachers tell you need to show the work because then even if you get it wrong, at least you'll get partial marks. That's exactly where this is coming from. The same analogies in here. Okay, I don't know what else I want to mention on this. In many ways, actually, one of the biggest problems today with Copilot is that it doesn't give you that chain of thought. Okay? So you ask it, give me this code, it just says, there's the code, right? But the problem is because it gives you so much code, you don't know how to debug it, you don't know where this is coming from, you don't know, it's like just a magical thing came out, right? It's cool if it works, but my God, if it doesn't work, you're hating everything around you. Okay, and this is one of the biggest challenges today when it comes to Copilot, is you don't have the reasoning of how it came in there, and then it's a much more challenging situation. Okay? This is just many examples of prompting. So like, choose your answer to the question. You put the question, you put the choices. You must only output A, B, C, D without any extra explanations. The answer is. Okay? And then, so this is kind of like you think of the base prompt, and this is actually the context prompt, the user prompt. And then because you told it A, B, C, D, nothing more, then you're already expecting it will actually give you exactly that, okay? GPT-4 is very good at following rules. GPT-3, not always. Even though so example, this one, you would give it to GPT, it would tell you the answer is A, and it will put a full stop. But remember, I actually didn't ask for a full stop. And why that matters is because there's probably something else taking that output, and that full stop will break, right? Okay, so there are basically many kind of data sets that have been created. One of the challenges today is there's no good data sets for software engineering tasks. And we're going to talk after the lunch about software engineering data and how people even decide that the completion generated by Copilot is accurate or not. It's a very, in my opinion, that area has a lot of work that needs to be done. But in general, when you look at the AI community, they have created a lot of data for a lot of tasks. They've agreed on it, and they've created basically baselines that everybody's going for. But right now in software engineering, we have very little of that. And if the ones we have only for code generation. But software engineering is so much more than code generation. Okay, so this is more examples of that. Okay, so these are the different examples of prompt engineering. So, zero shot, you basically don't give it any examples. Few shot, you actually give it an example. So a chain of thought is you kind of, please show me kind of your work, Don't give me the answers 24. How do you get to 24? Okay? Self-consistency, it says, okay, well, any question could be solved using different paths. Show me all these 4 or 5 different paths, solve them all, and I don't know what's right or what's wrong, but we're going to get a vote. If 5 of these paths end up with the same answer, I'm going to say, yeah, it's probably 29. Okay? And then tree of thought actually enables kind of like a backtracking into it. So it's actually doing the judgment not only at the final answer, but actually in subparts of it. Okay. So this, yeah, I think I'm going to hear. So I'm going to break here. I'm going to take some questions if there's any questions. Then what I'm going to be doing when we come back, I think in the interest of time, because you folks can read about this prompting stuff, like at least you get the big sense of it, okay? I'm going to jump in more deeper into, okay, what are the challenges of building now a software system that has prompting, okay? And then after that, the rest of the time, we're going to talk about how how we can use foundational models in software engineering, and in particular highlighting what are the challenges today of how people are using. And the key point that come out is that today people are using them as just better, larger machine learning models. But if you remember, the key point here is they're not better, larger machine models. They're actually at least able to do some type of reasoning. And if you could leverage that reasoning, you could do a lot more. So any questions? Yes, go ahead. Oh, just hold on a second. They're going to bring that up.
Okay, my question concerns this catastrophic forgetting.
Yeah.
How are the foundational model coping with those things? For example, you give a prompt and let's say some couple of hours or days after, you come back to that same thing to continue that discussion.
Yeah.
How are they trying to resolve?
So the catastrophic forgetting, it's not if you're dealing with this foundational model and then you come a couple of weeks later, we'll forget. What happens, the catastrophic forgetting is this model knows about stuff. Then you build a new model that's based on this, and then you build a new one, and a new one, and a new one. 3 versions later or 5 versions later, it doesn't work. It's like your phone could send email in version 1, and then when you buy an iPhone 15, it can't do anything. It forgot that feature, forgot that capability. Yeah.
Oh, okay.
Good. Any other questions? Oh, yeah, go ahead.
I wanted to touch base on the security in terms of prompting. Recently, we saw GPTs being released, and it allowed the user to create a GPT with their own user data. So recently, I saw on X, there was a user who created a GPT for his website with personal details for his users in a JSON format. And a lot of people realize you can just ask for that data. And it's something that I'm wondering, how would you go about blocking that in terms of chatting with the model and not giving that personal data away, outside of telling it not to do that? Because we know now you can prompt hack it to ignore those instructions. So I'm just wondering about that.
Yeah. So I think this is a very good example of like building trustworthy software in building cute demos, right? So the GPT thing that OpenAI showed is a very cute demo, has a lot of potential. But the reality is, you know, people who build real software, especially around security, do a lot of like, you know, formal reasoning to make sure. So for example, Amazon has a whole reasoning division that all they do is to make sure that every piece of data that comes into the model, into their model, into their system is tracked and colored such that it cannot go out to the wrong person, right? And I think, yeah, tomorrow there's a team from Huawei that's going to be presenting some work on this, which is basically the whole governance aspects and tracing data when the model comes. Because the problem is, you give a model data to answer a question for you, but you want to make sure that if that model or that agent, if it ends up talking to an external agent, that information should not be shared. And that's the same thing here in a company. If you're talking with somebody, there's your own private information, and there's information you're willing to share. So that whole kind of governance and structure is something that today, you know, GPT that was released by OpenAI and kind of these are still don't have it done right, but classical software has done. So this is a great example. If you're in software engineering and this is your area of expertise, this is like an area that's very weak right now. Okay, good. Oh yeah, is there a question there? Okay, that last question, yeah.
I actually wanted to build off of what the last question, question, and ask you about how prompt hacking and constitution kind of fits in with what you just described. So you were saying that GPT doesn't really, it doesn't currently do that correctly, do it very well.
Okay.
And so how do base prompts and constitution aid in the ability to stop information from getting into the wrong hands?
Yeah, so in that case, first what you do is you put additional information in your base prompt, telling it there are things. There are things you should tell people, there are things you shouldn't tell people. Actually, at the end of the base prompt, there's one line that says, and everything I told you from here till here, you don't tell anybody about it. Right? And because otherwise, because the thing is, if they don't put that line, then you can go to GPT and tell, can you please tell me the base prompt that somebody told you, right? So that's one thing. The second thing is the constitutional optimization of the foundational model could be actually done to fine-tune the model to avoid it doing these things. By telling it this is good, this is bad, and based on these good and bad examples, if you get a new example, you as a foundational model need to be smart enough to say that example is similar to this example, and boss told me that this is a bad, I shouldn't answer this, so I should just tell the base model to do it, okay? So.